we did all this, if you remember, on Monday. And it's coming, it's coming, it's coming. I want to go a little fast because I can only load about 10 minutes worth of video. So if you go back to your notes, the paper that you had yesterday, where is it? This guy. Remember this guy? Yes. Pull that out from the notes from Monday. And we're looking at the part that says flow proof. The very bottom says flow proof. Very bottom, you should have an empty box still. We didn't get to that one. We're doing it right now. Alright, so let's do it right now. Jump over to the screen with me. Here we go. Triangle angle sum theorem. Here's what this says. We're talking about a triangle. Boom, boom, boom. You know this already. You've heard of this already. So let me just go quickly through it. It says this. The angles in a triangle add up to 180 degrees. 180 degrees. You know that already. So call this angle A, call this angle B, call this angle C, and we know that angle 1 plus angle A plus angle B plus angle C adds up to 180. Alright, so we're going to use that rule. These three have to add up to 180. Alright, the angles, not the length of the sides, the angles. Alright, come over to the other page. The back side. The last side of your pages. I feel like a hostage with the newspaper. I'm in geometry class. Alright, here we go. Triangle classification by angles. Different types of angles, different types of triangles. You know this already also. You've seen this. You're right, you tripped on the camera. Alright, here's what we have. When all three angles are the same, they are 60 degrees. Because again, they have to add up to 180. So if they're all the same, it's 60, 60, 60. Which means that this is called an equiangular triangle. Equiangular means equal, and then angular, equal angles. Kind of fun. It's nice, I like it. This one, what is that? That looks to me to be acute. And remember, acute is where all the angles are smaller than 90.
Aww.
It's a cute triangle. You want to squeeze it through its cheeks. It's a cute one. Never mind, don't squeeze the cheeks. This one is a right triangle. Has a little box right there. Means that one angle is right. That means 90 degrees. This is a right triangle. Over on the right, go on, follow me. All right, there you go. Thank you. On the right, this angle is bigger than 90, so it's called an obtuse triangle. So these are all kinds of triangles: equiangular triangle, acute, right, or obtuse. All right, moving over to the other side. Classification by side. So that was by angles. If you want to name the angles by side, here's what you have to do. This guy, again, it's equal angles, but more importantly in this scenario is that all the sides are the same size. All three sides are the same. So this is called equilateral. Equilateral. Again, equi means equal. Lateral means sides. So equal sides, all three sides are equal. This little fellow over here, this little piggy went to the market. This little piggy has two sides the same size, and as you might remember, if you say it already in your heads, it's called isosceles. Isosceles triangle. And then the last one, these are all different sizes. This could be like 6, this could be like 3, and this one could be like 7. If they're all different sizes, hello. This is, forgot it. Nah, I'm just kidding, I know it. Scalene. Alright, so those are the different classifications of triangles. Then we have one little piece of information. Bottom of the notes, getting to the end. Here's what we have. Definitions. I'm going to make this bigger. An exterior angle. What is an exterior angle? It is an angle on the outside of a shape. On the outside of a shape. Or in this case, a polygon. Alright, again, that's not the official geometry definition. That's just Giraldi's simplified version. So, for example, if I want to draw an exterior angle, it would look something like, let me draw a triangle here. I'll draw a triangle in here. if I extend one of these lines, then the outside being this angle right here, that's the exterior angle. It's not in the triangle, it's outside of the triangle, therefore it's called an exterior angle. Alright? Remote interior angles. Remote interior angles. As the name says it is, they are interior angles. Angles inside the shape, or inside the polygon. Polygon. Far away from the exterior angle. What are you talking about? I'll give you a moment to catch up and hopefully make sense of that scribble scrabble chicken scratches. You got it? Yeah, this is the eye. It's the stink eye. Better behave. You know what I'm talking about? Yeah, you behave. Alright, okay, zoom in. Let's go back to this. None of this messing around. So what are we going to do? If you're looking at this little fella, so this was called the exterior angle, yes? Because it was outside. These little two guys are called the remote interior ones. Because they're inside and they're far away from this little fella. This guy is interior, but he's right next to it, so he's not remote. Remote means removed from, far away from. So these two are remote interior angles. This one is not, because it's right next to the exterior one. Here's what this theorem says, and here's what we finish up with these notes. The triangle exterior angle theorem says this. If, and only if, you have an exterior angle in a triangle, that exterior angle equals these two guys added together. Huh? What? I know, I confused myself on that one. Call this angle W for now, just for the sake of it. Here's what this says. This theorem says that angle A plus angle B is equal to angle W. These two remote interior angles equal, when they add up, they equal the exterior. Alright? So, just to throw another example on you here. Say this angle is 30 and this angle is 80. That means that this angle out here has to be 110 because it's this guy plus this guy equals that guy out there. Alright, not bad. Alright, let's try a couple problems and see you in a moment. So, number one is the one I'm going to do here. Looking at page 134. Looking at page 134, you have a triangle. These are pretty easy. I know Victoria's like, let's not do what I wanted, that was too easy. But that's Victoria for you, aka Veronica, also known as Catherine with a C. They want to know that angle. This angle is 117, this angle is 33. They all have to add up to 180. So you just add those plus that mystery angle equals 180. So you just punch that into your calculator if you have a calculator. If you don't have a calculator, like I don't at the moment, you gotta work it out the hard way. It took way longer than it should have. 180, subtract it, 30. That's our blank angle 1, 30. Alright, where'd you go? Okay. Where'd I go? He disappeared. He's under the table again. Alright, I'm only going to do the first one, so I'm going to do the first one on every slide. That's what I'm going to do. Alright, so can't fight about it. No waiting 20 minutes for Victoria to make up her mind. Here you go, number 6. Find the value of each of these variables. So I have this amazing, beautiful triangle that you will find in your book. This guy's 80, this guy's X. This little guy up here is 30. This one's 40, this one's Y. This is Z. They would like you to find all the different variables. So just look at this little triangle right here. Just look at that. If you're looking at that triangle, this is 80, this is 30, that's 110 together. They have to add up to 180. That means that this one right here has to be 70. So X is 70. Now if X is 70, if this angle right here is 70, then this other angle which adds up to make 180 because it's a straight line, means that y is 110. And then now I'm going to look only at, what am I going to look at? I'm only going to look at this slanted triangle here, this obtuse triangle. Look at that triangle. This angle is 40, this angle is 110. Together that's 150, which means that this one right here has to be z is 30, because that makes 180. Remember, they all add up to 180. All right, let's do maybe one or two more problems, and then I gotta go, because this is all the time I have. My plane's leaving. Number 12. Plus, these aren't that hard, right? You can get these. Number 12 says use a protractor and centimeter rule to measure the angles and the sides of each triangle. Classify each triangle by using the angles and the sides. All right. So there's this little triangle. They want you to measure it so that you can notice that they're all different lengths. I'm looking at number 12, and it looks. If you look at number 12, it looks like they're all different lengths. If they're all different lengths, that means it is scalene. Although you might want to double check that one. I didn't take a ruler to it, but double check it. And then the angles, all the angles are less than 90. It looks like I'm still looking at it. Yeah, all the angles are less than 90. So that means it's also acute. Alright, so we'll do one more. There you go, one more. Bam! Number 16. For this one, they want you to draw it. You. Do your artistic abilities. Let them out. Express yourself. Mark the triangle to show the information. They want you to draw an acute equilateral. Equilateral just means all three sides are the same size. All three sides are the same size. Let's pretend those are all the same size. And you would label it by putting little dashes like this. That means they're all the same size. And that's it. If you can't draw it, then you would make it not possible. It's not because you suck at drawing, it's because it would be possible to draw it. Alright? That would be the reason why you can't draw it. Alright. And I think that might be it. I'm going to let you struggle with the rest. And I will see you on Monday.